We're not going to beat the dead horse here. We've seen that y equals a to the x is an exponential function. In this case, a is greater than 1 because we have exponential growth. And its inverse is y equals log base a of argument x. And it's the mirror image over this line, y equals x. They are inverses. They are connected. And we had all sorts of rules for exponents. Like if I gave you a to the 0, you know that's equal to 1. And that was one of many rules that we learned. Correspondingly, we learned that log base a of 1, the answer to the log problem is the exponent. A to what power gives us 1? Oh yeah, that's 0. So we see a connection there. Of course, there's going to now be properties of logarithms that we should know as well. Properties of logarithms. Let a be a positive real number such that a does not equal 1. Let n be a real number. If u and v are positive real numbers, then our product property, log base a of, the argument has to be something times something, u times v. That will give us log, notice the base stays the same, of the first, plus log, base stays the same, of the second. Notice, please, that one log becomes 2 logs. We're splitting up the log into 2 different logs, and we take the product halfway through the product, and we put each of the factors as an argument of that same base of that log. Notice something we've seen before with exponents, multiplication associated with addition. The quotient property, log base a of something divided by something, is split it up. 1 log becomes 2 logs with that same base. Log of the numerator minus log of the denominator. We saw that when we were doing polar form of imaginary numbers or complex numbers. And lastly, log, what did we see? Division associated with subtraction. Also with exponents, division is associated with subtraction. Log a of u to the power of n. Now, our argument here is u. That's the argument. Look what happens here with the power product. The exponent can migrate down in front of the log and become a coefficient. So log base a u to the n becomes n log base a of argument u. I personally think it's very important to learn these properties backwards and forwards. The product property, going from 1 log to 2 logs, log a u v, split it up, is log a u plus log a v. But be able to see that we can expand from 1 log to 2 log, or we could contract or condense from 2 logs to 1 log. Log a u plus log a v is log a of product u times v. It's this times this, argument times argument. Similarly, with the quotient property, backwards and forwards, 1 log becomes 2. We're expanding this. Log a u over v becomes log of the numerator minus log of the denominator, and whatever base we had carries through. But also be able to condense this. If you're given 2 different logs with a minus in between them and they have the same base, we can write 2 logs as 1 log. Because I'm writing 2 as 1, I'm saying I'm condensing. Because I'm writing 1 log as 2 logs, I'm expanding. So this would be log a of the first divided by the second argument. When we are expanding a log expression, one of the last things I usually do is I take the exponent and I migrate it down in front here to fully expand the log, and it becomes the coefficient of the log. Now, if I'm given that, please note that the argument in this case is u. There it is. Now, to condense, one of the first things I do is, if I have some expression like this where the argument is u, I pop that exponent up. It goes from a coefficient to the exponent as I condense the log expression. So this is our power property backwards and forwards.